All right. So we're going to get started because we have a lot to discuss tonight and a lot to cover. But first of all, if you are new to Voyage Fromage, you should have all your cheeses out and ready, and because we're going to dig in and taste as we're talking. But as you saw, first of all, my name is Julia. I'm the owner of Formaggio Kitchen, and I'm thrilled to welcome you into my home tonight to nerd out about cheese. And so tonight's theme I've actually thought about for probably almost a year in really wanting to incorporate this into one of our cheese clubs because it's really something that I think a lot of people don't think about or realize when they're eating cheese, and that is rennet. And more than that, the sort of coagulation of cheese. And so we're going to be deep diving into the various types of rennet and also an acid set cheese so that you can really understand the differences and why cheesemakers make the choices that they do to determine what type of rennet they're going to use to make their cheeses. And we have two very special guests tonight from the cellars at Jasper Hill, Zoe and Leigh, and they are going to be discussing their cheese, Alpha Tolman. And so very excited to have them talk about why rennet is so important to that cheese, because as they dig in, you'll see, and as you literally dig into the cheese, you will see why it matters so much. We are going to start with kind of the basic and go from there. And so we are actually going to start tonight with the ricotta. And I really wanted to send you all a acid set cheese. When you think about milk and cheese and what makes cheese cheese, the most important aspect, of course, is milk. So you have this liquid product that then becomes the cheese that you have on your plate. So how does it get from point A to point B? And of course, in the previous Voyage Fromages, we've always talked about milk and why the quality is so important and where it comes from and all of that. Coagulation is pretty much step two. So you have this beautiful milk product, and what is next? And I think a big question is, what type of cheese are you making? So we wanted to make a house-made ricotta for you because it is one of the oldest styles of making cheese and one of the most basic styles of making cheese. And it is a acid set cheese. And so what that means is the milk is heated to a certain point. Acid is added to the milk. In this case, it's vinegar, but you can also use lemon juice. And that process helps to separate the curd from the whey. And so we are going to be getting a little bit nerdy and talking a little bit about science tonight so that you can really understand why that happens. And so a protein that you're going to hear us talking a lot about that's found in milk, and probably the most important protein for cheese making, is casein. And casein is this really interesting protein that is covered with almost like little hairs. They just sort of like look like little hairy molecules. And in milk, these casein micelles, which is what they're called, float around and they bounce off one another. And that's how it is in the liquid state. So our goal in cheese making is getting these casein micelles to stick together. And that's going to be what creates your curd. And so the question is, how do you do that? And that's what we're going to be talking about tonight. And so because I'm going to share my screen really, really quickly, because we have, I just wanted to show you a little bit of visual of these casein molecules so you can see how these little hairs are what are causing them to bounce off one another. And then coagulation is getting those casein molecules to stick together. And so this is an example of those hairs having been essentially dissolved away in this sense, or clipped off, and they are sticking together. Now, I'm going to let the folks at Jasper Hill dig in a lot more into the science, but I thought this was a nice little visual to get started into where that coagulation happens. But because it's Formaggio Kitchen, we wanted to give you something really fun to create. And part of the reason that we sent ricotta, there's a lot of choices that we could have sent for an acid set cheese. I really wanted to send ricotta because I wanted to share with you my favorite recipe. And so my favorite recipe is actually, let me turn off the sound because, so my favorite recipe is for something called a ricotta spoon sweet. And this is just a quick little video showing how to make it. So all of the accompaniments that you have tonight are intended for you to be able to replicate and recreate this dessert. And so you can see I just added the ricotta into my mixer, and you can use a hand mixer or a stand mixer. And I'm slowly drizzling in the honey to sweeten it. And what you want to do is basically create a level of sweetness that suits yourself. I also, in the beginning, I don't know if you saw, added a little bit of cream, which is optional to make it a little bit fluffier. And then I basically let that mixer just keep going and going and going until I got a nice sort of fluffy, smooth, creamy ricotta. And then what I do is I spoon it into a little bowl. The spoon sweet that you got, we just started importing from Greece, from Chio, and they're known for their mandarin there. And a spoon sweet is essentially a fruit that is preserved in syrup. And so it's the perfect topping for, because it's already so sweet, it's the perfect topping for something that's a little bit savory. And so I absolutely adore it with the ricotta. You can, you don't even have to do the whole mixing process. You can just spoon it right over the ricotta right now, and it would be absolutely fantastic. But I think that the process of whipping it it's a very traditional sort of Italian way of serving a sweet ricotta. And you get that really smooth, delicate texture. And you're basically, as we're going to talk about more about curd, is you're breaking down that curd more and more so that it's really delicate and fine and smooth. And so just a little special way for you to enjoy that ricotta. So I hope that you like it. But without further ado, I'm very excited to introduce Leigh and Zoe from the Cellars Jasper Hill. And I'm going to turn it over to them to start talking about the alpha Hallman. And so you at home, definitely start digging in, taste the cheese as you're learning. And thank you guys so much for being here.
Thank you for having us, Julia. I'm like licking my fingers over here. The spoon sweet is so good. Everything. Okay. So I'm Zoe Brickley. I've been with Jasper Hill since 2009. And before that, I was a cheesemonger. So I'm in it to win it as a cheese professional. I didn't think that I would I'd become a cheese professional when I grew up. And it's been a really wonderful turn of events. I want to introduce my colleague here, Leigh. Leigh's been with us for 5 or 6 years, is a certified cheese professional. Do you have anything to say for yourself, Leigh?
Well, good evening. Thank you for joining us. Yeah, this is going to be fun. I feel like a student every time I do these. Like I live this Jasper Hill rennet that Zoe's going to get into. And I know the processes that we do, but gosh, cheese is just like ever fascinating. So no matter how big or small your knowledge is or how much time you spend with cheese, there's so much more to learn. So just enjoy the journey. And if you ever feel overwhelmed with some of the information, please just like raise a hand and ask the questions. Even for us who have been in it for some of us close to a decade or more, we still have a plethora of questions and you know, are constantly learning. So it can be overwhelming, but enjoy the cheese and ask the questions.
Yes, all of this comes from asking a lot of annoying questions to people who know more about cheese than me. That's my whole bag. Okay, so Julia, how long do we have? Because I'll go all night if you don't cut me off.
I mean, I'd say a good 30 minutes and then we'll wrap up with the last two cheeses.
Okay, I'll keep it moving along then. All right, so here we go. Oh, let me just see if I can get the screen share to work again. It worked before. Okay, here we go. Beautiful. All right, so give it a second and it should be in presentation mode. Are we good? We're seeing Jasper Hill Farm.
You're not in presentation mode, but we are seeing your slides though.
Oh, okay. So you're seeing like the opposite here.
I'm seeing like your whole PowerPoint, but yeah.
Okay. Well,
it's good enough if that works.
Good enough. Okay. You guys can have a little preview of what's to come.
Yeah.
We're in Google Meet and we're using Macs. And so they make it hard on purpose just to punish us. Okay, here we go. So, oh boy, this is going to be good. Okay, I'm not going to spend too much time talking about like the whole backstory of Jasper Hill because it's a long, beautiful story, but we'd be here all night. But I wanted to give you a visual of where I am, which is beneath a hillside behind this building that we're looking at. So we're in the Northeast Kingdom of Vermont, and that's literally in the northeast part of the state. Very remote, even more remote and lightly populated than the rest of Vermont. Andy and Mateo and their wives, Angie and Victoria, are the founders of our company. They bought this barn when it was run down. It hadn't been farmed as a dairy farm in a generation. They fixed it up.
Sorry to interrupt you. I'm just seeing the cropping center slide.
Amazing. Okay. Let me make sure you're looking at the right deck. You are not. Okay, how about this? No. Give it a second. We're going to do this, guys. We're going to do this together. Entire screen. Window. Okay, how about now?
Yes, there's the farm.
Okay, great. That probably explains it. I had too many presentations open. Okay, this is the farm in the Northeast Kingdom. This is the barn that was run down. And this is the little house, the tan house here that was restored. Let's see if I can get this into presentation mode now. How about that?
That's perfect.
Beautiful. Okay. So this is a creamery that was, designed to be attached to the side of this barn. And Mateo and his family live on the second and third floor that we can see here. And the basement of this farmhouse were the original aging caves. Here is an early days set of photos of this entrepreneurial set of couples. So there's Mateo, our head cheesemaker, his wife Angie, with her baby Bump, who has just graduated from high school. I can't believe it. Jasper Hill Farm just turned 20. This is Andy, who's always been taken charge of herd management and land management, and also functions as our CFO for sure these days. And his better half, Victoria, who is our original affineur. So she was taking care of the cheeses down in the cellar there. And then this is a nice snapshot of our earliest offerings about 20 years ago. And as we'll kind of chat about, those have expanded into a whole collection of different styles. Okay, and then early days, we partnered with our local cooperative. When we were the smallest, newest cheesemaker in the state, we partnered with the oldest, biggest Cabot Cooperative Creamery to make a cave-aged cheddar. The TLDR, long story short, is that it was an unexpected collaboration. Jasper Hill ended up selling it instead of Cabot because we were working with specialty shops like Formaggio that were really excited about an American cloth-bound cheddar and could deal with the limited quantities. And that won Best of Show in the American Cheese Society right out of the gates and allowed us to build this 7-vaulted 22,000 square foot underground facility to help us expand what had become a mission to bring value-added agriculture to our rural community and economy. So selling liquid milk is a really hard way to make a living, especially with 50 cows, which is the scale of the farm when we started. And if you can turn your raw material of milk into something more valuable by cave aging it into these beautiful European style natural rind cheeses, you can harness your destiny. So we jumped at the opportunity to create more space to be able to ripen more cheese sourced from milk nearby, fed local pasture lands. It's been a beautiful evolution. So I'm actually sitting in this building. Let's see if I can find myself here. I'm sitting right about here in the office. So I can look through the window and see the doors to what we call these cheese vaults. Each one has a slightly different temperature and humidity, so that we can perfect specific styles of cheese in there. Here's a photo of our cloth bound vault filled with that beautiful cheese made for us by Cabot Creamery, ripened here and represented by our team. Okay, so enough of that. Let's get on to geeking out. Okay, so just as Julia was describing, this is a more fanciful representation of a casein micelle, or bundle of individual milk proteins. So milk proteins are called casein, and a casein micelle is a bundle of those proteins. And just as she described, these chains of individual proteins are kind of capped off at the end by what's called a kappa casein. It has a negative charge. So you can picture the tip of each rubber band here in this model, this crude model of having a little negatively charged protein at the tip of each rubber band. And what that does is that it creates a sort of a sphere of negativity, just like two like ends of a magnet. That's what keeps milk protein floating around in liquid milk. So when we look at liquid milk, it's kind of bland and it's white, and it's amazing that something so boring could be responsible for such amazing, infinite possibilities of aroma development. And there's a lot of solids. There's fat and there's protein and there's sugar and minerals in that milk, but those particles are very small and they're staying equally dispersed in that liquid milk. And so the way that the protein stays evenly dispersed is by pushing away from each other because of these little negatively charged proteins kicking it around the edge. What keeps them bound together so they're not just all randomly floating around in milk are the minerals. So the calcium in milk, we know milk is calcium rich. It's like the glue that holds proteins together. So it lives bound up in these protein bundles. Okay, we also know that milk has lactose because we have friends who are lactose intolerant. This is the sugar in milk. It's really important for cheese making because the sugar that's there is really the potential acidity that's there. So Julia mentioned an acid coagulated cheese like the ricotta that you're enjoying. The acid in cheese is lactic acid. So it's the converted lactose that gets turned into lactic acid using starter culture, right? So lactic acid bacteria, starter cultures, are ubiquitous bacteria. They're all over us. It's how humans were able to discover fermentation, because you can't miss them. They're all around us. And there are many, many lactic acid bacteria that play a role in cheese making, either because you purchase them from a culture company or because they're already just around in your milk and in your environment. All right, we've got fat. The same way that milk protein aren't just little individual proteins floating around, they're organized into a package. Same with fat molecules. So we can imagine that in liquid milk, butter fat is packaged into beach balls filled with butter, right? We don't see raw butter cooling at the surface of warm milk when we're ready to make cheese. We might see a cream line, but all of that fat is trapped within these globules. These globules have a membrane that's negatively charged also, so they're pushing away from each other. They're pushing away from the proteins. Everybody's floating around, happy. Okay, a lot of it's water, of course. So when we want to make cheese, this is like the easiest way to describe what cheese making is. We add starter culture, or we turn up the volume, which we'll talk about, on the existing lactic acid bacteria around in the creamery. And we create a more acidic milk. Milk starts pretty much neutral pH, right under 7, so just slightly acidic, pretty neutral pH. And as those starter cultures, as the lactic acid bacteria eat the sugar and turn it into acid, a really interesting thing starts to happen, which is that you create a more soluble environment for the minerals. Okay, so you start to dissolve the calcium. So think about how acid rain pits concrete, or, you know, beautiful cement statues. The acid is dissolving away the minerals. What's happening is you're loosening up the glue that's holding your proteins together. So as you acidify the milk, your couche balls start to swell up, okay? And then before they go too far, we'll look at this in a future slide, you add rennet. Rennet is, it's a protein, and it's an enzyme. So rennet as an enzyme, enzymes, there's a lot of different enzymes involved in cheese ripening. And each enzyme has a special job to do. It's like a key that unlocks a lock, right? So every enzyme will go and attack a molecular structure in a predictable way. The specific enzyme associated with rennet that we're going to talk about, its special job in life, its special connection that it goes in and severs, is the tip of each of these rubber bands, okay? So its whole job is to go in and give these couche balls a buzz cut. When you add rennet, you're clipping off all these negative little charges that help the protein stay away from each other. And all of a sudden, instead of pushing away from each other, they want to bond on those little like open connections and grab onto each other. So when you're cheese making, you're using acidification from turning lactose into lactic acid to swell up your couche balls. Then you add rennet and let all your couche balls grab onto each other when they're all swollen up. And then you're trapping the fat and the water. So you create this like three-dimensional meshwork of protein that you've trapped a target amount of moisture in, and all of your fat. Okay, that's the that's the simplest way to describe a very complicated thing. So these are what we can think of here is like these are the ingredients of milk. And when you talk about the ingredients of cheese, milk, salt, rennet, and cultures, you kind of glaze over the fact that milk itself has all of these really important ingredients for cheese making. So now when we look at this simple, bland white jug of milk, we can imagine, okay, this is one ingredient in cheese making, but it has many more ingredients, these 5 other ingredients. So we've talked about the rennet, right, as another thing that you would add to the milk to get it to turn into cheese. And we talked about the starter cultures, the lactic acid bacteria. When you first start making cheese, you're going to add like any of the microbes that you want to be a part of it, if they're not already sort of native in your raw milk. So any other culture that you're going to add is like, usually it's freeze-dried like pixie dust that you're going to add to the milk. It could be the white fluffy flora that you want to grow on your brie. It could be the sticky orange bacteria that's going to grow on your wash rinds. It could be the yeast that helps set the rind and make a happy place for mold and bacteria to grow. All of those are called adjunct or ripening cultures. Basically, if they don't create acidity, they're lumped into a big, diverse group of flora that can do a lot of cool things for you. They could also be an anaerobic bacteria that's ripening a cryovac cheddar on a shelf. So just because a cheese doesn't have rind doesn't mean it's not ripened. Doesn't mean that it doesn't develop texture and flavor over time. Some microbes work inside the cheese without needing oxygen. Others work on the outside of the cheese, aerobically, we'll say. They get their jazzercise on. Also, there's salt, and then there's optional stuff. We're not going to focus on that today. Wish we could, but we've only got a limited amount of time. This is just a quick diagram about what starter culture do. They eat sugar, lactic acid bacteria. They make more of themselves exponentially. So at first, there's only a little bit of acidification, and then really gets ramping up as it goes. And the creamery starts to smell cheesy when these starter cultures are activated and doing their thing. They're making lactic acid, but they're also making cheesy aromas. So if you've ever had a cultured butter, somebody has added starter culture to cream after they've skimmed it off of the top of fresh milk. And they've developed these additional aromas, and then you churn that cream into butter after you've made it more flavorful and a little bit acidic, okay? Another cool thing about starter culture, and the reason why we love diversity of starter cultures, like you might buy some from a culture company, but with raw milk, if you're not pasteurizing your milk, you've got a number of individual starter culture lactic acid bacteria strains in there that are going to make individual cool flavors when they die. So they're filled with enzymes, and when they are done doing their job of making acid, they kind of give up, they break open, and they contribute a like porridge of enzymes. And those enzymes, just like rennet, are going to go in and chop up fats and proteins in a special and predictable way. So when you buy starter culture from a culture catalog, you can buy ones that make fruity flavors or floral flavors or mushroomy flavors. And they'll actually tell you, you know, what the predictable flavor is because of the way that they tend to break down fats and proteins. So cheese smell, cheese aroma, and flavor literally are tiny pieces of fat and protein that are chopped up so small by enzymes that they can get into your nose. I can't see your faces, but I'm imagining that they're all, your jaws are slack as you take this all in. Okay. So let's talk about rennet. Okay, I had to give you the like, here's how cheese making works using my symbology before I could really get into rennet specifically. So rennet is harvested from, some people like to say that cows as a ruminant, goat, sheep, cows, yaks, water buffaloes, camels, they are ruminants. They have a 4-chambered stomach. They don't have 4 stomachs. You will get yelled at by a biologist if you say that out loud in public, as I have. They have 1 4-chambered stomach. And the first chamber, A, here is the rumen. You can picture it as the lawnmower bag of the cow. They're out eating grass, and their rumen is packed with fresh green grass. Or in the wintertime when they're eating hay, it's packed with hay. It's surrounded with big, powerful muscles that are agitating the contents. And of course, there's gastric juices. Those are enzymes that are helping to break down the feed, and trillions of microbes, okay? So it's like a big fermentation tank. The second stop on the cow's stomach, the B, is the reticulum. This is the place that senses fibrousness. And if your cows feed, they're eating grass and hay, you have a suitably fibrous diet, that creates a cud ball because the cow uses her molars to further break down that fibrousness in her diet. So that's a really healthy and important part of cheese making, is making sure your cows are getting enough fiber and that they're healthy and relaxed and feel like chilling out and ruminating, we call it. So she'll burp up a cud ball from the reticulum, has these little fingers that sense fibrousness. She chews them between her molars, breaks them down, helps it create more surface area for microbes to attach, and her saliva actually helps the microbes stick to those sheared fibers. Okay, then she swallows that again, gets another ball going. It's this cool cycle. And then the broken down fibers can pass go, and they can get into C, the omasum, that helps dehydrate this like watery mash of broken down, partially fermented stomach contents. And then D, this is where the magic happens for rennet. This is the abomasum. This is the closest thing to a human stomach in the cow. So she had to do all of that stuff just to get her food to a place where it can be digested, quote unquote, normally. So humans could eat grass all day and we'd starve to death. She can turn it into butter, which is a magical thing. And her 4-chambered situation is how she does it. The abomasum, so when a calf hasn't started eating solid food yet, it's an unweaned calf, the abomasum is making a bunch of a specific enzyme that turns liquid milk into solid food so that the calf has more time to digest it, right? If it was all liquidy, it would pass through their system before they'd have a chance to like glean the nutrients from it. So the abomasum in a young animal is designed to coagulate their liquid diet into solid food. It makes perfect logical sense. Somehow, like 9,000 years ago, literally, humans figured that out, and they figured out how to use abomasums from young animals to coagulate milk and preserve it. Basically, they're able to acidify, dehydrate, and salt milk. And the rennet is the really important part of dehydrating, because you're able to coagulate the curd and separate the curd from the whey. Okay, so humans are weird and smart. Cows are magical creatures. Okay, we're doing good. We're moving on. Okay, so this is where I got koosh balls and beach balls, these illustrations. And I borrowed these illustrations from Harold McGee's On Food and Cooking. It's a big, fat, red book about food science. The first couple chapters are on milk and cheese making, and I love him for that. So that was his chapters are written in plain English. They're designed to help chefs understand the science of the techniques that they use. And it really helped me wrap my head around how this all works. So what we're looking at here is the difference between a lactic set and an enzymatic set. A lactic set cheese is really well illustrated by Veronica's cheese, the Blakesville Creamery Lake Breeze that you have. It's this adorable little puck, and it has a wrinkly rind. It's a great example of a yeast-dominated rind. And it's got this like cakey, chalky texture. So what's happening here, in the case of Veronica's cheese, it's a microbial rennet. Okay, so it's considered vegetarian. I'll talk about what that means. But basically, there is, she would add a lot of starter culture to liquid milk and let it sit in a warmish room in order to really get that starter culture going, get that exponential reproduction going, get the acidification happening. After a good period of time of letting that initial acidification happen, she would add a little bit of this microbial rennet relative to other recipes to make a lactic set cheese. And then she's going to leave that curd alone, or that milk alone, for like 12 to 24 hours. I don't know specifically what she's doing here, but it's an extended acidification process. You really are using acidity to drive the cheese making process. And look what happens to your koosh balls. You swell them up so much by letting them just acidify like indefinitely that they fall apart. You dissolve away all of the stuff that's holding them together. And when you add that little bit of rennet, you're clipping off that the negatively charged little hairs around the outside of your koosh balls, and you're basically just creating more ways that the protein can then kind of bond back together. But what you end up with is a very fragile curd. This curd, when she would come back to it ready to make cheese, would be a lot like yogurt. And she would take probably a ladle and ladle out a scoop of that yogurt, and that's considered cutting the curd. And then she would put that into a perforated cup to drain. That it might fill up the cup when she does the first scoop. Once she fills up all her little cups, she'll go back to the beginning, and that's kind of shrunk because it's drained moisture. She'll get a nice even ladle out of it, and then she can fit another ladle in that cup. And it might take, I would say, looking at this cheese, 5 passes, 5 scoops per cheese to get that curd all the way in there. And then it continues to kind of shrink and drain over time. And you end up with like a very fragile, cakey curd, right? You try to bend this cheese and it breaks short, like shortbread cookie dough. That's really different from maybe the Alpha Tolman, even though that's a very different, firmer textured cheese. The Alpha Tolman is a great example of an enzymatic coagulation. And so that has way more organized and structured proteins, and you get more of a bend to it because there's still a lot of the calcium left there. In the case of a lactic set cheese like the Blakesville Creamery cheese, you lose all of that minerality to the whey. And so you really have a demineralized curd, we say, and we don't have the glue that holds the curd together. And you end up with that crumbly, in this case, almost cakey texture. That's exactly what that cheese is supposed to be like. This looks beautiful to me. Okay, so on the other hand, in an enzymatic coagulation, and this is basically like, if it's not a lactic set cheese where it has this like young kind of cakey appearance, basically all other cheeses are falling along a spectrum of enzymatic coagulation. And what's happening here is you're adding starter culture. You let that get going a little bit. You let your koosh balls swell up, loosen, just maybe loosen up a little bit. And then you add a lot more rennet than you would with a that your koosh balls stay pretty well stuck together. There's a lot of glue still there. We haven't dissolved it all away. And then you end up with like a rubbery curd. So if you dropped the Lake Breeze on the floor the day after you made it, it would splatter. If you're familiar with like the Harbison that we make, or maybe a more typical like American bloomy rind cheese that's a little more bouncy in texture, that would literally bounce off the floor if you dropped it. Harbison are very bouncy and rubbery the first, like right after they're made. even though they have the same amount of water. It's just the protein is way more structured and it's holding everything in. And as that rind develops in both cases, it's going to be loosening up the structure, letting the water out, and your cheese. Okay, so that's what we're talking about with these two kinds of coagulation. And now I can give you a little bit more. I'm supposed to be, Julie's like, just talk about animal rennet. And I'm like, okay, well, I'm going to start from the beginning.
No, this is perfect. Keep going.
Okay, cool. All right. So we talked about where animal rennet comes from. I'm going to show you some slides about how we're using some traditional methods in the context of a modern creamery to prepare our rennet. But basically, there are facilities, mainly like all located in Europe, that specialize in preparing abomasums as a byproduct from like the veal industry and creating very specific and like validated strength jugs of animal rennet that you can just straight up buy off the internet. You can order it from a specialty culture house, but they're all very similar in what they are and the strength, that strength has been tested. But when you see the word rennet on a label, that generally indicates that it is from that traditional animal rennet, even if it's commercially prepared. When you see the word enzymes on a label, or vegetarian rennet, it usually says enzymes. That's signaling to this microbial rennet. So this is not directly derived from an animal. Like a long time ago in a lab, they used a little bit of bovine genetics to alter a mold, Mucor mayhi or something. I'm probably pronouncing that wrong, but a type of mold. And they figured out how to like edit a gene in the mold with the bovine gene so that you can like put it in a laboratory setting, feed it a specific food it likes, and it cranks out the key enzyme associated with animal rennet, which is chymosin. Okay, so you can basically make a bunch of chymosin in a lab using a lightly genetically modified mold. And that will give you a product that you can put in a cheese and call that cheese vegetarian, or if a rabbi is present and you go through all of those standards, you could create a kosher cheese with a microbial rennet, because it isn't like for each batch derived from an animal. Like an animal was involved like decades ago once. Okay. And this is super typical. Like any cheese that you would get from the grocery store is probably going to be made with microbial rennet. You're likely only to see animal rennet associated with like artisan cheeses, but it doesn't mean that artisan cheeses like Veronica's beautiful Lake Breeze here can't be made with microbial rennet. So each cheesemaker is going to have a different reason and motivation for choosing one or the other. The third one that we get to talk about today, which I am so excited about, is vegetable rennet. So not the same as vegetarian rennet. It is actually from the stamen of like a wild cardoon thistle. For whatever reason, it's just like chock full of like a blend of enzymes, including chymosin, but like a bunch of other stuff. So the Zimbro today is an example of a thistle renneted cheese. This is one of like, you picked my 3 favorite cheeses for this class. I'm so excited. I always look for soft ripened thistle renneted Spanish or Portuguese cheeses. Julia can tell us more specifically about Zimbro, but like whenever people ask me what my favorite cheese is, and I'm like, doesn't count Jasper Hill. Okay, if it doesn't count Jasper Hill, then it's basically Zimbro. Zimbro is a great example. I love them. They have a lot of complexity, a lot of like wild flavors. There can be kind of animally and fruity, and they're just usually very aromatic and complex because there's a range of enzymes that are going to be chopping up fats and proteins and in a diversity of ways beyond the ability to go in and clip off that little negatively charged protein. The other important thing to mention here, like in terms of like the enzymatic blend, like microbial rennet is basically like pure chymosin. Vegetable rennet derived from thistles is a diversity of enzymes, including chymosin. Animal rennet is 80 to 95% chymosin and 5 to 20% pepsin, which is which is the reason why a cheesemaker might choose animal rennet, because there's that secondary enzyme that's associated with naturally derived rennet that helps kind of further break things down. Depending on the cheese style and the milk type, there is a risk of bitterness with microbial rennet if you don't work against that. And part of it is because chymosin will kind of partially break down proteins beyond. They're clipping off their little negatively charged hairs, and partially broken down proteins are bitter on the palate. If they continue to be broken down by other microbes and their enzymes along the ripening journey, they get so small that they're no longer bitter and sensed on the tongue. They can get up into your nose and become aromatic. So if you're not careful when you use microbial rennet, you can have kind of like a stalled protein breakdown that stalls out in the bitterness phase before it goes aromatic. And pepsin, the complement to chymosin in the animal rennet, helps that continuation of breaking those proteins down, so you're less likely to stall out on the bitter phase of protein breakdown. I have to ask Mateo that question every time. I literally texted him before this presentation to be like, remind me why microbial rennet is associated with bitterness again. And now I think I got it down. Okay. Okay. Wow. This chart. Wow. Okay. You guys, I'm going to come back to this chart. I'm going to show you some photographs of our creamery, but first just look at this, marvel at the complexity. This is the perfect example of why we say at Jasper Hill, we take the path of most resistance instead of least resistance. We're like, we could buy rennet, or we could do this, which is super cool and geeky, but also quite complicated. So I'm going to explain this to you, but first I'm going to show you in a little bit more illustrative detail. So this is super cool. These are French dudes who are preparing vels, so salted and dried abomasums. We call those vels, V-E-L-L-E-S. And they are, I'm not quite sure like what they're doing. It looks like they're trimming them so that you only get the good part. They're also like rubbing them. Yeah, it looks like you trim off the top part. Okay. And then he's kind of like, yep, he's doing that. That seems important. Okay. Cool. Loosening it up. Great. So that's pretty much what we buy, are those like little balloon bags. That step there this is a precision incubator. So we're going to talk about this in our chart, but this is what I mean when I say precision incubator. Look, it says it right there. We labeled it. Basically, it's a hot water bath, and we're putting some whey in there that we take off of a make. And when you put whey that you, once you make a batch of cheese, you separate the curds from the whey. We're literally just taking the non-curds. We're taking the whey, putting it in this cute little stainless steel container and putting it in a hot water bath. And what we're doing there is we are like making a lot more of that starter culture. We are turning up the volume on our own starter cultures that are associated with our raw milk. And this cheese specifically, instead of having to like buy a lot of starter culture. So that's one part of it that I'm going to reference. Okay, we're incubating whey. We're incubating whey. Now, what Allison, one of my personal heroes and our creamery manager of our newly renovated creamery, is doing here, she's taken whey from what I just described, turned the curds into whey, and the whey goes into this little mini vat here. And she is ladling out ricotta. This is very similar to what you guys are enjoying with your spoon sweets right now, okay? What you received in your box. So this is, when I showed you that first slide of the koosh ball and the beach ball, there was like a little rubber band down at the bottom that said whey proteins. So not all of the proteins live bundled up cute in those koosh balls. There's a bunch of like free agents kind of floating around, and you don't catch those when you make curds and whey. They tend to still hang out in the whey. So the whey still has a good amount of protein in it. That's why you can like feed it to pastured pigs, and it's like really nutritious for them because it still has a lot of protein. What you see here is Allison is clarifying the whey by making ricotta. We've already created some acidity in the cheese making process. And now she's heating that way up, and it's knocking those proteins out of suspension so that she can ladle them out. And so ricotta comes from the Italian words for recook. And the French would say recuit. So we've recooked the whey in order to capture those loose proteins. We just take those home in deli containers and eat them. We take turns taking home the day's ricotta. Cheesemakers seem to be a little sick of it by now, because whenever I go there, they're like, we'd love for you to have this deli container full of ricotta, and it's usually like still warm and like, oh, it's such a treat. Okay, so we've made ricotta. That's important, not because of the ricotta, which is like a bonus, but because of the clarified whey, which is a really important part of this process, this overly complicated process that I'm going to try to describe to you. There it is, right? So pulling out the solids. And, you know, from a gallon of milk, you might only get like a tablespoon of that whey. Sorry, I started this over. We'll get back to where we were. Don't worry. Okay. Here we go. Yeah. Okay, now we're going to see some shredded vels, right? So the gentlemen who were preparing these like kind of bags, they look like, we shred them up into what this is here. And these are abomasums. We aspire one day to be able to harvest our own abomasums from the male calves. It's a whole thing. We're not there yet. One day, but in the meantime, this is super cool. Basically, nobody is doing this in the United States that I know of other than us. Okay, so we got these little shredded vels, and now we're going to cook them up, weigh them very carefully with that clarified whey, with that what we call recuit. Okay, so we're gonna like let it sit and incubate in like at a very specific temperature. And what the crazy thing about that is when you let the clarified whey and the shredded vels like chill for a while, it becomes like so acidic and enzymatic that it basically completely liquefies those shreds and they like disappear. And you end up with this like crazy, like souped up enzymatic porridge that also has like a good amount of lactic acid bacteria. And then what we're doing here is that the precision incubator, we had put some of that fresh whey in there in order to get a lot of that lactic acid bacteria going. So when we did the vel thing, we're really focused on extracting enzymes. Incubating the plain whey really focuses on isolating the starter cultures, those lactic acid bacteria. And so now she's taking a little bit of that incubated fresh whey to add to some of her vel mixture there. Yeah, there it goes. And again, I needed someone to remind me about all of these different steps. And then, I don't know, that's more of that. Okay, so I think I did it. Now, let's see it in action here. So she's getting some milk out of the vat. There's already been starter culture added to this. No, okay, this is the starter and rennet. Okay, so that's just fresh milk, warm milk in the vat. She's taking some of this mixture that we just talked about making and putting it in there at a super high concentration, which basically like instantly coagulates it. And she can tell when she looks at that it's at the proper strength by like super dosing a little bit of milk. And that's what she just did. She's like, yep, instantly turned into curd. Great. I'm going to go ahead and add it to the vat. And after a little bit of time, you can see we're starting to get that yogurty texture, right? Once it's firm enough that it doesn't just smush out, that you can actually get a good cut out of it, we would turn on these, they're called harps. And these are cutting and stirring curd shapes. And the cutting, after a certain point, we might take out the harps and just put in paddles to stir. But we're trying to get this curd cut down to a pretty small size. As an Alpine style cheese, we're aiming for like lentil sized curds. Okay, this looks like a wildly like industrial operation, but I assure you that like this crazy contraption can only make like 30 wheels of cheese at a time. So the beautiful copper line vats that we just saw in the last images, those were salvaged from a Comté producer in the Jura Mountains. We somehow figured out how to salvage and restore those vats during the pandemic, mostly over Zoom with French engineers and electricians and welders. We had one French like superstar who we managed to like smuggle into the country during like visa lockdown, who basically like helped us build this whole plant. This piece of equipment we also salvaged and restored from that Comté producer. And what this is, these are big, they call them bells. So these are 4 bells, and each bell is going to be like, we're vacuum feeding gravity feeding the curd. The vats are up here on the 2nd story, and they're like flowing down into the bells. And then each bell uses vacuum technology to suck out the excess whey and create a super nice, tightly knitted curd. We were making alpha Tolman before this, but we ended up with like really inconsistent curd texture, and we never got this beautiful, tight, velvety, supple texture. One of the first batches of cheese we made with this equipment, alpha Tolman's like softer, higher moisture, more melty little sister Whitney, won best of show at the American Cheese Society, like one of the like first 10 batches that we made with this new equipment. It was incredible how much this equipment, which has been like engineered to mimic these traditional techniques, has made such a huge difference for our quality. So this is like the biggest, fanciest piece of stainless steel that we have now. I promise you that it is outsized looking for the scale that it makes. And you can see if we hit play again here, the big curd blocks that each one of those bells is going to create. It's basically this big square that we cut into 9 individual 22-pound wheels of alpha. So you can see those are hand loaded into round molds, and then they get put into like a hydraulic press, and then they turn into round wheels in those forms. So we can make basically 4 times 9 cheeses in a single make from these 2 copper lined vats. Okay, I think, all right, that's a metaphor. So I think with all of that, we can look at this diagram and not just go like cross-eyed. Okay, so what we saw was cheese is made. You have curds and whey. Some of the whey goes into that tank that we saw, gets cooked, and you get ricotta, and you get clarified whey, the recuite. This is the French word for clarified whey, dealbuminated whey, whatever. It's like you take the ricotta, those loose proteins out, that's what you're left with. Okay, some of the fresh whey, before it goes into the cooking process, gets incubated in that precision incubator, right? That's pumping up the volume on all the lactic acid bacteria that's there. So all the starter cultures that helped us acidify this batch, we've captured with the whey, and we're making more of them here. And then we add some recuit to that, some of the clarified whey, and we add the vels. And then that's what we call our Sax booster. It's named after Anne Saxelby, one of our dear friends and longtime collaborators. Okay, so that's that part of it. And then separately, we make some, and this is just like a little bit of vels, okay? So up here, what we're really focused on is bacteria, but we have added like a pinch of vels to this process for a little bit more of the native starter cultures and rennet enzymes that's associated with those vels, okay? That's what we call our Sax booster. Then we take some of the clarified whey, we add a lot of vels. This is like 50-50. So this is really what we saw that video of where she was stirring it around. And then this is pretty much what you'd consider to be traditionally prepared rennet, okay? We add those 2 things together with a little bit of the previous day's Sax rennet that's been sort of curing, we'll say. And then we add that to the next day's make, along with a little bit of yogurt. And so the yogurt is fresh milk that we've inoculated, that we basically like incubated with a little bit of commercial culture, just to make sure that we've got all of the types of starter culture that we need in there. And then the make is done, and then we start that process all over again. So it's basically like an enzymatic microbiosolera that continues on forever and is sort of like self-referential and gets refreshed through this process. So like I said, it's a lot of work, but what you end up with is a really interesting terroir-driven cheese made with traditional methods. We're obsessed with, our raw material down to the soil microbes and the grass. So this is a nice little metaphor for that. The cows are taking in all of this complexity, simplifying it into a bland, colorless liquid. It goes into the cheese. We put it in the cheese caves. It's got all of this, like these microbes and potential. And then as we ripen it, all of that complexity and beauty that the cow took in the form of grass and fresh air and sunshine comes radiating back out of the cheese. Okay, so I think with that, I better call it. If you want to see a shot of our hay dryer before I shut it down, this is what we do. We harvest fresh grass. If it's too wet to dry it in the field, we can put it in this cool shed we built that forces hot air up through it. Fermented grass, which is like the big white marshmallows you see in the fields up around here, is like a way of fermenting grass that's too wet. It would rot if you didn't ferment it. So you put it in an anaerobic bubble. That's great. It's good for the cows, but it causes cheeses like Alpha Tolman to like bloat and get little gas bubbles. And so again, path of most resistance, we dry it.
Thank you so much. So that was amazing. And I'm so glad you were able to touch on the Lake Breeze and the Zimbro as well, because I think putting them all together and understanding how they all kind of work harmoniously makes a lot of sense. And I think, I'm going to talk very, very briefly before we end the night just about intent. And that was the number one thing when I was talking to Veronica of Blakesville Creamery, who makes the Lake Breeze, is intent. Because if you know Veronica, she's making cheese to make the best cheese possible, not to please other people. And so she's not using microbial or vegetarian. She's not making a vegetarian cheese for the intent of it being vegetarian. And so it was really fun to talk to her about the trial and error process of this cheese. And, she said she did experiment with a kid rennet. But she said that there is one commercial kid rennet kind of on the market, but it's exorbitantly expensive. And it just made the cheese way too goaty and farmy for her taste. She tried traditional rennet, animal rennet, and she felt that the cheese was too young and didn't have time to break down the pepsin, which gave it kind of a little bit more of a bitterness that she was unhappy with. And then she tried going the microbial route, and she loved the coagulation. She loved the flavor. For her passion is milk and using, fresh goat's milk and not frozen curd. And as you can see by the cheese, it's one of my favorites too. I absolutely love it. And it's truly a great expression of the cheese and the milk, and intent is important. And when you're talking about the Zimbro, which is from the Serra da Estrela Mountains in northern Portugal, it's an area where they didn't have a lot of calves available. It's primarily sheep, which is again why this is a sheep's milk cheese. And so again, I talk a lot about kind of the anthropological history of cheese and why cheeses are made the way that they're made. And so frequently it's just because you're using the tools that you have at hand. When you're talking about hundreds and hundreds of years ago, if you're surrounded by these cardoon thistles, which is the case with this cheese, then that is how you that is the process that you use to make the cheese. And I think it's a really the Zimbro is one of my all-time favorite cheeses. I'd say most of you guys got very, very pristine versions of Zimbro. I myself really like it when it gets really funky and moldy. But and a couple of you got that, and I encourage you to eat the rind. Yeah, so Zoe's is like that is a very young, pristine version, and so you get it in all types, and they're all really good. And that's what I love about these small artisanal cheeses, because it really, whatever state the cheese is in, can be enjoyed just as a different style in a different way. And something that's really fun about the Alpha Tolman actually is Mark, our head cheese buyer, and I went up and Leigh took us on a tour of the caves and a tasting. And so we actually were able, gosh, when was that, in October? I think it was October. It feels like years ago, but it was October. And that's one thing that's very important to us, is hand selecting our wheels. And so we were able to taste through various batches and pick the wheels that we enjoyed the most and that we felt like our customers would enjoy the most. And we do the same with our Comté. And when we can, we'll do it with our Gruyères. But it's just it's a special process that kind of really exemplifies the fact that, as you can see by everything that Zoe presented, I always like to think of cheesemaking as choose your own adventure. And there's a million different pathways you can take. And so there's so many different avenues to make a different batch taste different. And when you get to artisanal cheesemaking, it is not about consistency. From my perspective, it's about the ebbs and the flows, and appreciating the differences in the batches, and appreciating the highs and the lows, so that, when you do get that batch that's absolutely exceptional, you appreciate it that much more. And from the cheesemaker's perspective, I know they always love to dig in to understand why that batch was the way that it was and why it was so exceptional. But Zoe, I want to thank you so much for that incredible presentation. I mean, I think we were true to our word that we were able to geek out tonight. And I really, really appreciate the insight that you brought into describing, how we coagulate milk, and, sort of the beginning stages of cheese making and why it's so important. Does anybody have any questions before we sign off tonight? I hope everybody enjoyed the cheeses and enjoyed the spoon sweet. It's brand new for us in the US. We just started importing it, so I hope you like it. And the honey, I should say, is from a local producer in Harvard, Mass. And he puts his hives in apple orchards. So we only buy from him once a year, because we get it after all the blossoms are out and all the honeybees collect from that. And it's such a lovely little honey, and it's really nice to support a little local beekeeper. And if you struggle to get that top off of the honey, boil a little water and just melt the wax in the boiling water, and a wine bottle opener, and you're in business. So that was the trick that he taught me. So any questions before we sign off for the night?
I just want to say I love this alpha. Like, your selected alpha is really a treat for me, because we usually taste like luck of the draw coming out of the vaults, but this is a special piece of cheese. It's so fruity. It's like roasted hazelnuts. The texture is spot on. It's got those little crunchy crystals. So it was really a treat to be able to try all of these cheeses. Thank you.
You're welcome. I'm so glad. It's fun to be able to kind of have the cheese literally come full circle, because, it spends a little bit of time in our cave, and then we break it open, and then, to be able to go to you and then see again, I think that's a really special part of the process. So, terrific. Any questions before we sign off? If anybody does have any questions afterwards, if you want to dig in a little bit deeper about any of the topics, you can always shoot me an email, julia@formaggiokitchen.com. I've said it a million times. Any cheese question at all will get you the right info, whether it's cheese you bought from us or elsewhere. We just want to be able to share some good insight. And if there's no questions, I want to thank both Leigh and Zoe so much for taking the time. They are snowed in Vermont right now. So I hope that we gave you some nice, delicious provisions to last through the storm. But thank you again. Really, that was an absolutely wonderful presentation. And for next month's Voyage Fromage, I'm very excited that we have confirmed a tour of the Parmesan Caves by Giorgio Crivero. And so he's going to walk through with his son Giacomo, who's probably going to be the cameraman, and show us all his aging facility and kind of the principles behind why he ages the cheese the way that he does. So hopefully you can join us for that. And it'll be a little bit of a different time and day. We're going to do it on a Saturday midday because of the time change. But we're still going to do it live. So it'll be a lot of fun. He's a great guy and a great personality. So hopefully you'll be able to join us. So thank you again and have a wonderful night and enjoy your cheeses.